can I say? 10 seconds. Okay. Fine. I can start now.
Okay, we're good. So can I welcome Laszlo Papp, who's here to give us an ONS introduction and demo. Thank you so much, Laszlo.
Thank you everyone for coming, and I am very pleased to be here. So I think this is the first time that ONOS is talked about at FOSDEM. So it's quite exciting, and I would like to just give you some taster about ONOS and what ONOS is. Maybe a short icebreaker would be like, how many of you heard about ONOS before? Uh-oh. That's very good. So, well, I still hope that I can provide some information, and maybe you can ask questions so I can also learn from you. So I'm actually an ONOS ambassador. It's not a big title or anything, but that just means that I'm keen on using this technology, and I'm keen on advocating it to others as well. So what I'm going to talk about is basically, I would just, for those, and also for those who know ONOS, but those who don't know what ONOS is, maybe just explain the architecture briefly and the use cases. Hopefully we will have a very, very brief demo, 1 minute, and then maybe just a few words about the community and how you can join it if you like hacking on open source projects. So ONOS comes from the background, basically it comes in terms of SDN, so it's traditionally the world was such that there were many devices in the networks. I mean, there are many devices in the networks, and quite often these are like closed platforms. They come with their own protocols. It's provided by the vendor, and even the software that controls the functionality very often comes from the vendor. So there is very little space for researchers or open source developers to actually customize these devices and these systems. So they have to always comply with whatever the vendor is providing. So that's the kind of the background where SDN is born. So there is what we call data plane, which is there were a lot of talks about how to optimize that part of the stack, but there's also the control plane, and ONOS is actually in that domain. So ONOS is more concentrating on the control plane itself. So yeah, it's just again just summarizing. There is the forwarding hardware functionality in the hardware. This is coming from the hardware vendors. Actually, I also work for a hardware vendor company, so I'm coming from that side of the software stack. And then there is a network operating system, and then there are applications on top of that platform, which, you know, all kinds of applications can be implemented. In a way, I would probably compare it to the Linux kernel itself. That's why it's also an operating system, because in many ways, when you write drivers for these forwarding hardwares, you actually write like a device driver in a bit different sense, but the philosophy is kind of like the same, and then the applications would compare to user space applications sitting on the top of the Linux kernel. So this is a centralized platform, and the use case is really that in data centers there are so many hardware devices and applications that need to be provided, that the variety and the matrix of these is so complex, and there was a need to have like a centralized platform to manage all this. So in a data center, I just read 2 years ago in a book that in a big data centers that, for example, Google has, there are 70,000 virtual servers running. So it's really huge scale. So ONOS is an open network operating system. So I very much compare it to the Linux kernel in the networking domain. So it's completely open. It's meant for networking for this use case. It's written in Java. That's definitely different to the Linux kernel. So it's a bit higher level language and very much object-oriented and all these things. The license is Apache. It's open source, so it's available on GitHub, so you can clone it yourself to see it. There are quarterly releases, so the last one happened actually just this month. The next one will happen in April, either before Brexit or after, I don't know. So just the ecosystem briefly. So this is very important. This slide is more just to show how much it is used and how many industrial collaborators are investing into this project. So it's definitely not a toy project, not a personal repo from someone. So it's actually backed by many big giants in the networking field, including Cisco. You see all these. I think even Intel. Yeah, Intel is also there. So many of these companies are behind this project. There is a very active board deciding according to service provider use cases. So this is very much industry driven. So briefly just about the architecture. So this is roughly the architecture of ONOS, which is basically an operating system for the networking field. So there is a core, which I would compare to the Linux kernel, where you have the core, the actual kernel itself. Then there is what we call the SB core API. That's the Southbound core API. I would very much compare this to the driver system in the Linux kernel. So you can write device drivers for various devices. Even for one particular device, you can write multiple drivers for different protocols. Then there is what is called, sitting on top of the distributed core is the Northbound core API, and then the apps. But I think I will just go through explaining each of them very briefly and why they are there. So obviously the distributed core is where the abstraction is happening, high availability is happening, which is very important in network systems, and scalability, performance, the distributed storage. So all the kind of logic or algorithm is happening inside that. So that's basically the craft of the whole thing. So the distributed core also makes sure that the scalability is good. So like I said before, in big data centers, like there are so many network devices. So it's very important that these are just pluggable into the network, and the ONOS is basically still up working. So it doesn't matter how many more devices you connect to it will keep working. Or similarly, if you connect servers into the system host, then that is also like not a limitation in ONOS, that you can scale up the network like that. So this is just an example. In this case, we have various network devices at the bottom in the network, and at the top we have multiple servers, multiple hosts, and they are all equal. So those are there to provide high availability. So in this case, if one host is running at fault, then another host will take over. So it's not going to be a problem for the network at all. So all the hosts are running the same code, the same release basically. So they have their own internal protocol for communicating all this takeover. It's a consensus protocol. So the next thing very important in the architecture is the northbound interface, because this is where the actual network services, network applications are written on top. So it provides key abstractions. Probably I won't go very much into the details, but I think the main point for network operators and network architects is that they can write applications explaining what the application, the network service should do, as opposed to how. So it's a way in ONOS to what we call intents. So it's really the network operator can express their intent, as opposed to connect this device to this device, this device to this. No, you just say these end devices, connect them, and ONOS will work out what the intent, how the intent should be actually implemented. So the next thing which I worked actually personally a lot with is the Southbound core API. This is where the network drivers are written. But again, it's not network drivers in terms of the Linux kernel. but in some way they are very similar because there is a strong abstraction so that you can plug in any device. It doesn't matter whether it's an optical device, whether it's an Ethernet device, whether it's running OpenFlow, whether it's running SNMP, netconf. So it's possible basically to plug in anything. And yeah, it's just a few examples of these. So what I worked on personally is OpenFlow. In fact, that's how I started this whole ONOS thing. In fact, even before ONOS, I was working with Open Daylight, because ONOS got only open sourced in 2014. I started in 2013, and we started with OpenFlow, and gradually we got more requests from customers to support netconf on our devices or SNMP. P4 is a new upcoming way of programming devices, basically. And a couple of other examples, like even like REST or RESTconf, these are very popular for network providers. So these are what they are all implementing in different ways. Sometimes these protocols are not exactly implemented in the same way by vendors. So this is what writing a driver in ONOS means. So then we come to the applications. So this is probably the most interesting part of the stack for network operators, because this is where various applications can be written. So this is just one example where ONOS in the middle, it can function basically as a service in Openstack. And I haven't mentioned this, but it's kind of given these days that ONOS is also providing Docker containers and Docker images. So actually, there are nightly builds. So even the very new stuff can be experimented with and tried out. So ONOS is providing that, and in this way, an ONOS instance or a set of Docker containers that ONOS provide, they can be plugged into the Openstack world, and then it can function as a service. And this is practically how it's done in terms of architecture. So yeah, ONOS provides containers. It can be run in VMs. In fact, the demo that I will show that is also using VMs and Docker containers. So this is not a problem. And then some more use cases. It's probably a bit too many to show, but I'm not trying to show this on a per item basis, just to show that there are so many use cases out there that can be done with, that can be used for, that ONOS can be used for. So there's an interesting project. I forgot to mention that ONOS is coming from the Open Network Foundation, and they're also working on a project called Court, where they are basically into all kinds of things. So data centers, providing services for data centers, telecommunication offices. So 5G projects and all kinds of data center projects. And because this is actually a developer conference, just to show, because running short on time, but basically just to summarize, developing an ONOS application is not any different to basically any other way of developing applications in other projects. You just clone the code. So like I mentioned on the first slides, it's available on GitHub. You create your application or clone an existing one and adjust it. Write your code. It's written in Java, the backend, and the front end is written in JavaScript. The build system is currently switched to Bazel, which is a new build system. And then again, you launch it, you activate applications. It's all based on OSGI. So some of you, if you are familiar with the Java world, it's very common to deactivate applications, drivers on the fly without affecting the running production instance. And obviously, you test it, you debug, and you release it again. So I will just show how ONOS looks like when it is used. So this is one of the Northbound interfaces. It's a GUI. So this is actually a network topology. Yeah, this is America. And this is how the GUI looks like. So you can see here, like, there are multiple hosts. So they're all in charge of the whole network. So if there's a failure in one, the other will take over. And this is just the GUI. We have a console-based interface as well. I personally use that the most, but it's just what I prefer. It's not really required. And we have a REST interface. So ONOS has a REST interface for interacting. So many applications can be written using the REST interface. And then you have the usual Swagger, which is the providing the REST API documentation. So it's generic. And I will try to show the demo if it works. There should be a play button somewhere.
Worked yesterday.
It worked yesterday, so.
Let's go out of full screen mode. See if
Yeah, maybe you can you check? There used to be a button at the.
There used to
just
be.
the play button. Or maybe we can just go to the slide and play it from there.
There we go, there, yeah, and that's... And then if we go back, is that playing?
It's not playing still. Can see. Something is not right. Sorry. No, not at this moment. Okay.
I'd say just don't go full screen, just play it.
Just play it from. Yeah, okay.
Right click on it and it's
Yeah, that's what it was meant to be, yeah. Okay, so it's. Doesn't seem to show us a video. Oh, okay. So that's it. So this is the ONOS GUI that is being demonstrated. So there are all kinds of views in the GUI. So this is the intent view, where you have your intents listed. They have IDs, type, and this is like a simple topology view. In this case, it's using optical switches because that's the background I'm coming from. But it's not limited to optical technology at all. So, yeah, so you can see there are several nodes. You can see their IDs. And, yeah, then a cable is plugged out there. Just let you read. Yeah, so there are also flows in the system. So obviously everything that goes beyond between the elements, those are flows, even for optical switches actually. The abstraction of flows are preserved. Yeah, so in this case the idea was that if you remove the path, then the topology will recalculate everything, and it just shows that the consensus works and how the topology changes. Is it okay. Maybe it's a bit long, so I will just go to the next slide. So the community again, there is an ambassador program in ONOS. That's how I got into it as well myself. So it's very accessible. The community is very open, very friendly. We use Garrett for code reviews, and this is just a map of the contributors all over the world. So there's a lot in Europe, also in America, also in the East. And yeah, just quickly the takeaways. So ONOS is production ready. That's the critique it used to get in the past, but now with actual real deployment, this can be proved that it's production ready. It has a distributed core. It's modular, so if you write code in one area, you don't affect the other code. It's high performance, scalable. It's easy to extend. It's easy to use from CLI, GUI, and REST. And yeah, it simplifies the network. It's open source, and it has a great community. Thank you very much.
Bang on time. Thank you so much.